Picture this, a car that doesn't just drive, it learns. It adapts to your habits, predicts traffic before it happens, and even senses road conditions it's never seen before. That's not science fiction. It's the power of a neural network. Think of it as a digital brain, inspired by how we think, but supercharged with silicon and math. Let's peel back the layers and see how this revolutionary tech actually works. At its heart, a neural network mimics the human brain's web of neurons. But instead of flesh and blood, it's built with layers of code. The first layer? That's the input layer, your car's eyes and ears. Imagine sensors soaking up data, a camera spotting a pedestrian, a microphone hearing a honk, or a radar detecting a slick road. This raw data is the starting line. Next up, the hidden layers. This is where the magic happens. These layers are like the car's engine room, crunching numbers to find patterns. Let's say the camera sees a red octagon. Is it a stop sign, or a red balloon? The hidden layers debate this, weighing clues. Maybe the shape is too round, or the location, floating in the sky, doesn't fit. Layer by layer, the network narrows it down. By the time it hits the output layer, the decision is made: hit the brakes. But what makes this system so powerful? Three things. First, depth. More hidden layers mean sharper precision. Think of it like upgrading from a sedan to a Formula One car. Deeper networks handle complex tasks, like spotting a cat in a meme or predicting stock market trends. Second, activation functions. These are the traffic lights of the network, deciding when a neuron should fire. Names like ReLU or sigmoid sound technical, but they're just rules that say, okay, this data is important, pass it on. Or nah, ignore that noise. Third, weights and bias. Imagine tuning a guitar. If the strings are too tight, the notes screech. Too loose, and it's a mumble. Weights adjust how much influence one neuron has on another. Bias? That's like giving the network a hint: prioritize sharp turns in rainy weather. Together, they fine-tune decisions for smoother, smarter results. Now, let's talk performance. Neural networks aren't born geniuses, they're trained. Think of training data as the high-octane fuel. Feed it blurry, biased data. You'll get a clueless AI that mistakes a trash bag for a dog. But give it millions of clear, diverse examples, stop signs in rain, snow, fog, and it becomes a pro. Training uses a trick called backpropagation. Imagine teaching a kid to ride a bike. When they swerve into a bush, you say, lean left next time. Backpropagation does the same. Every mistake, like misreading a speed limit sign, triggers adjustments. The network tweaks its weights and biases, inching closer to perfection. But speed matters. That's where GPUs come in, the turbocharged engines of AI. A regular computer chip might handle one calculation at a time. A GPU? Thousands. It's the difference between a bicycle and a jet. Without this power, training a network could take years, not hours. Now, here's the real kicker: neural networks are adaptable. Once trained, they're not stuck in their ways. A network built for self-driving cars can pivot to diagnose diseases or compose music, if you retrain it with new data. Unlike rigid, old-school software, it learns without needing a total overhaul. But they're not flawless. Too many layers. The network might overfit. Picture a student who memorizes answers instead of understanding concepts. It aces the practice test but bombs the real exam. Too few layers. It underfits, like a driver who panics at every unfamiliar intersection. Balance is key. So, why should you care? Because neural networks are everywhere. They're in your phone's face unlock, Netflix's recommendations, even that spam filter saving your inbox. And this is just the start. Future networks could design life-saving drugs, tackle climate change, or create art that moves us. But here's the twist, they're only as good as we make them. Flawed data breeds flawed AI. Bias training. You'll get biased decisions. That's why the humans behind the code matter just as much as the tech itself. So, next time you see a Tesla navigate traffic or ChatGPT whip up a poem, remember, it's not magic. It's layers, data, and countless tweaks. And this? Just the beginning. The road to AI's future is long, unpredictable, and full of pit stops. But one thing's clear, we're not just passengers. We're the engineers, the teachers, and the drivers.